Hi, welcome back to the mechanical workshop. Today, we'll be recycling a washing machine motor. These are BLDC direct drive motors, which are highly ideal for building a wind generator. The first step is to disassemble the outer rotor assembly and remove the stator with its copper coils from the holding bracket. Inside, the cover is a strip of permanent magnets. The technician is using a screwdriver to check the magnetism. Next, remove the central spline shaft and any excess exterior mechanical components. Use a high-power heat gun to soften the thread-locking adhesive, making it easy to detach the base. The goal is to completely simplify the motor assembly, reducing its weight and eliminating mechanical friction. Reassemble the magnet cover back onto the original stator core. At this point, the assembly has been transformed into a generator. As the rotor spins, the magnetic field sweeps across the copper coils, inducing a three-phase alternating current. Use pliers to cut off the plastic connector plug, freeing the three-phase wires in preparation for connection. Check the smoothness of the bearings. The shaft spins smoothly, proving that the current starting resistance is extremely low. This is a three-phase bridge rectifier, rated at 1600 volts, the core component of the circuit system. This bridge diode functions to convert AC from the generator into DC power. Clamp the three-phase wires to the AC input terminals. Then attach alligator clips to the DC output pins. Perform a bench load test with a DC LED light. Just a gentle spin by hand is enough to light it up. Mount the generator system onto a fixed stand. Attach a red fan blade to simulate rotational inertia. The LED responds incredibly fast, showing good efficiency and meeting the standard voltage threshold at low RPMs. Moving on to machining the rotor hub. On a galvanized steel plate, use a compass and ruler to sketch a regular hexagon. Use an angle grinder, equipped with an alloy cutting wheel, to precisely cut away the excess metal edges. This perfectly cut hexagonal gusset plate will be the load-bearing center for the 6 blade arms. Firmly clamp the plate onto a mechanical vise. Use a hand drill to make a perfectly centered shaft hole. This center hole requires absolute precision to prevent centrifugal wobbling when spinning rapidly. Next, use a cut-off saw to divide a square steel tube into smaller sections, preparing to complete the vertical wind-catching frame. Arrange the 6 square steel tubes evenly around the plate to shape the rotor frame. Arc weld the square steel tubes to the 6 corners of the metal hexagonal disc. Use an angle grinder to clean the surface welding slag, ensuring an absolutely flat contact surface. Precisely measure the dimensions on a U-shaped aluminum channel and mark the load-bearing cut points along its body. Continue using the cutoff saw for batch cutting, cutting the aluminum channel into vertical connecting joints. The technician, equipped with a welding mask, tack welds the vertical bars to the ends of the arms. Insert the second spider disc into the top shaft assembly to form a cylindrical cage structure. The welding process to finish the rotor frame connections requires skill to avoid warping and thermal deformation. Apply an anti-rust fluorescent spray paint to the frame to increase its resistance to harsh weather conditions. The blade material is a large PVC pipe. Wrap masking tape around the body to draw perfect reference lines. Make a decisive, perpendicular cut using the grinder to exactly halve the length of the PVC pipe. Use an aluminum flat bar as a ruler to mark vertical baselines along the pipe in preparation for splitting it. The pipe is secured on a homemade wooden jig. Glide the cutting blade along the center to split it apart. This continuous cutting process is repeated to craft 6 aerodynamic curved trough-shaped blades. Use a resistive electric stove to locally heat along the cut edges of the PVC panels. When the plastic reaches its softening point, use pliers to bend the edges outward, creating a wind-catching lip to increase the drag coefficient. The painted and dried rotor frame is test-fitted onto the central pipe pillar to check the clearance margins. Permanently secure the PVC blades to the metal arms. Using a series of deep thread self-drilling screws, assemble the 6 curved trough blades onto the directional steel spider frame structure with the cylindrical pipe blocking turbulent airflow. Mount the stator and rotor generator assembly to the bottom flange of the blade chamber. Use an impact wrench to secure the main shaft lock nut to the steel plate. This step guarantees absolute concentricity. Hoist up the entire vertical axis wind turbine assembly. The system's weight is optimized thanks to the PVC material. Proceed to crimp terminals for the 3 electrical phases, connecting them to the built-in socket on the generator casing. Perform a final overall inspection of the wind turbine assembly. Cut the 3-phase wires and drop them down, waiting to be connected to the rectifier. Move the materials up to the roof area. A galvanized round steel pipe is used as the load-bearing mast. 1. Use L-shaped brackets and a power screwdriver to firmly anchor the base of the pole to the reinforced concrete wall. 2. Transport the wind turbine to the installation site. This vertical axis mechanism is perfect for catching multi-directional wind. 3. Position the generator mount on the top of the pole. Thread the AC phase wires through the pipe to protect them from the weather. Tighten the mounting flange to secure the system. Ensure the turbine is perfectly statically balanced in the vertical direction. Use an impact wrench to lock all the bolts securely. The tall steel pole reaches up to catch the cleanest airflow. Set up the solar charge controller circuit. Integrated with voltage management. Screw the terminals to connect the power sources. 1. Connect the DC output of the bridge rectifier to the energy input port on the charge controller for central control. 2. Connect the telecommunications lead-acid battery system. Tighten the terminal screws to eliminate contact resistance. 3. The screen immediately shows the battery voltage as 12.2 volts. Connect the load wires to the discharge control port of the charger. 4. The technician operates the screws to supply the DC load. The control circuit automatically prevents deep discharge to protect the battery. Set up a quick connect terminal block, allowing for flexible changes to the power-consuming devices. The aerodynamic turbine self-starts and spins incredibly smoothly. The vertical rotor design delivers instant high torque. Turn on the load switch. The DC LED light shines brightly, proving the excellent current performance of the system. The screen displays 11.7 volts when running the load. The motor, a recycled BLDC, acts as an excellent generator. Use alligator clips to start an additional 12 volts electric fan. The fan spins rapidly, showing that the direct current is very flat and stable. The system maintains multiple energy loads simultaneously. The turbine continuously converts the wind's kinetic energy into clean electricity. A drone captures a panoramic view of the power station. The wind turbine, combined with the solar panels, creates a hybrid solution. 4. The technician stands next to the mechanical engineering achievement. Even in light winds, the air scooping blades maintain excellent RPM. Under the sunset, the turbine spins quietly and rhythmically, providing independent green energy, a perfectly satisfying engineering project.